Hello friends, in the last video we have seen how to apply Newton's second law to a system that contains two objects and these two objects are having same acceleration, that is they are having same magnitude of acceleration and they are having same direction of acceleration. So in such cases basically you can consider a composite system, overall system, and you can apply Newton's second law and you can solve for the unknowns. But now in this video we will discuss a system that contains two objects but these two objects are not having same acceleration. That is, they can have different direction or they can have different magnitude or they can have both direction as well as magnitude is different. For this problem we will consider a case when the magnitude of two objects is same but the direction of acceleration of these two objects are different. So the objective of this session is to learn about how to solve two bodies with the same magnitude of acceleration using Newton's second law. And this we will illustrate using a problem. So this problem says the figure shows an air track glider with a mass m1 moving on a level frictionless air track in the physics lab. So we have a glider of mass m1. So this is the glider. And this glider is moving on this air track. So this is the air track. And this air track is kept in the physics lab. And this air track is basically friction. So this part is frictionless. So there is no friction between glider and air track. The glider is connected to a lab bait with mass m2 by a light, flexible, non-stretching string that passes over a stationary frictionless pulley. So this glider is connected to mass m2. This is kept in the lab. So this bait is kept in the lab. So we are simply attaching this mass with this glider using a string. And the property of this string is given, that is, this is a light string, flexible string and non-stretching string, and this passes over a frictionless pulley. So this pulley is also frictionless. Now we have to find the acceleration of each body and the tension in the string. So we have to find acceleration of each object and the tension in the string. So in this case the target variable is, so what is the target variable? Acceleration of each object and the tension in the string. And what are the things that is given? So we have been given mass m1 and then we have been given mass m2. So masses of each objects are given, that is m1 and m2. So m1 is given and m2 is given. And we have been also given properties of a string, that is a light string. So the string is massless. So we can assume the tension throughout the string, that is this point, this point, this point, or this point, or this point, it's same. And we call this tension as T. And this is also given, this is a non-stretching string. So string is not going to stretch. It's not going to elongate. This means if this point of a string moves by an amount x in this direction, this point of a string will also move amount x in this direction. In fact, all the points will move by the same amount. So we can say acceleration of mass m2 is acceleration of mass m1. So both are having same acceleration and we will assume that this acceleration is a, then this acceleration is also equals to a. So both are having the same acceleration and this is frictionless. So there is no friction here. So we can assume this is equals to mu is equals to 0. No friction here, mu is equals to 0. Now how we will solve this problem? So you see in this case this object and this object are not having same acceleration because one is moving along the y direction, another is moving along the x direction. So they are having same magnitude but direction is different, and that's why we cannot consider a composite system. We have to consider in this case two separate objects, that is one object is glider, another object is bait m2 and that is mass m2, and we have to draw the free body diagram and then we can solve the problem. So let us first draw the free body diagram for glider. So let us draw the free body diagram for glider. So we can show this glider using a point, and the beat is acting, and this will be acting in the downward direction, and the magnitude is m1g. And on this glider a normal reaction will also act. So this is the normal reaction that is acting in the vertical direction, and the string is trying to pull this glider in this direction. So a string will apply a tension, and the magnitude of this tension is T, and this glider is moving in this direction with acceleration A. Now let us write or draw free body diagram for mass m2. So this is mass m2. So once again I will show this using a point, and the weight is acting in the downward direction, and this is m2g, and tension is acting in the upward direction, and this is tension T, and this is moving in the downward direction with acceleration A. So we can show the acceleration A somewhere here. So now once I have the free body diagram ready, so this is the free body diagram for glider. So this is the free body diagram for the glider, and this is the free body diagram for mass m2. Now I can use Newton's second law, but before using Newton's second law I have to set the axis, that is sign convention. Now in this problem we will use direction of acceleration is a positive direction. This means this mass is moving in this direction. I will consider this is a positive direction. So this is my bi-direction, and this is my positive bi-axis. So this is positive bi-axis, and this mass is moving in this direction, that is this direction. So we will consider this direction as a positive x direction. So this is my sign convention for this problem. So now using this sign convention or using this axis we can write equation of motion. So let's first write equation of motion for glider, and we can write equation of motion for x direction first, and then we can write for y direction. So in the x direction for glider we have only one force, and that is tension. So we can write tension is equals to, that is force is equals to mass into acceleration. Mass is m1 and acceleration is a. Because this is frictionless, there is no force or friction force is acting along the x direction. So this is my equation number 1 for glider in the x direction. We can also write equation for the glider in the y direction. So in the y direction there is no acceleration, and the force is acting m1g is in the downward direction, and my downward direction is positive, so I can write m1g, and normal reaction is in the upward direction, and upward direction is negative. So force is equals to mass into acceleration, and acceleration is 0 in the y direction for this object. So I can simply equate equals to 0, and then this is my second equation. Now similarly I can write equation for mass m2. So let us write equation for mass m2. So you see this object is moving in the downward direction with acceleration a. So we can write m2g is the force that is in the downward direction. My downward direction is positive, and tension is acting in the upward direction. So tension becomes negative. So this is equals to force on the bi-direction on mass m2. Force is equals to mass into acceleration. Mass is m2 and acceleration is a. This is my equation number 3. So this is for bi-direction. Now in this case for mass m2 there is no point of writing an equation in the x direction, because in the x direction there is no force and there is no acceleration. This means this is simply 0 is equals to 0. Now I can solve these two equations. So what I can do is I can plug the value of t from 1 in equation 3. So from 1 in equation 3. So this is from equation 1 in equation 3. So I am simply writing 1 and 3, that denotes equation 1 and equation 3. So from 1 I can write t is equals to m1a. So equation 3 is nothing but m2z minus t is nothing but m1a, and this is equals to m2a, and this gives you m2z is equals to, I am taking this right hand side, so I will have m1 plus m2a. Now if you solve this, you can get basically a is equals to m2z, and this divided by m1 plus m2. So now I can write this acceleration is nothing but m2 divided by m1 plus m2, and this multiplied by z. This also makes sense because this is a dimensionless quantity and acceleration will have a dimension of z. So this is mass by mass, so there is no dimension in this case. So this is the acceleration of both object, the mass m, and this glider also will have the same acceleration. Once I know the acceleration, we can also calculate tension in the string, and tension is nothing but m1a as I showed earlier. So from here I can write t is equals to m1, and acceleration we just calculated, that is m2z divided by m1 plus m2. So this becomes m1 m2 divided by m1 plus m2, and this multiplied by z. So tension is nothing but m1 m2 divided by m1 plus m2, and this multiplied by z. Now see the dimension of tension. So this is dimension of force, because this will have a dimension of mass, because one mass will cancel out, so this will have a dimension of mass, and this is a dimension of acceleration. So you can say the tension will have a something like in Newton. Now we can consider two special cases. So a special case, the first case we can consider what will happen if m1 is equals to 0. This means there is no glider, or glider has a 0 mass. Now if you see this equation, we can calculate acceleration by simply putting m1 is equals to 0. So this m1 is equals to 0, so this becomes simply a is equals to m2 divided by 0 plus m2, and this multiplied by z. So this gives you a is equals to z, and that basically makes sense. If there is no mass, this is 0 mass, there is no mass, this means this mass m2 will fall freely. So there is basically gravity. The acceleration of mass m2 will be z, because this will fall under the gravity. Now the second special case, that is about tension. So when you will have tension is equals to 0, so either mass m1 can be 0 or mass m2 can be 0. In that case tension will be 0. So either mass m1 is 0 or mass m2 is equals to 0. In both cases you will have 0 tension, and that makes sense. This means if there is no object here, you will have no tension in this string, because this string is simply hanging from the pulley. Same way, if you have in this case there is no mass m1, in that case again, so there is no mass m1 in this case. So if there is no mass m1, then this is simply freely falling, and this string is slacked. So this means there is no tension in this case. So in this video we have seen how you can basically analyze a system that contains two objects, and these two objects are having same acceleration, but in magnitude wise same, but the direction wise they are having different the different acceleration direction. And in those cases you cannot analyze this system by simply considering a composite system, but you can analyze this system by considering two objects separately and drawing the free body diagram. In fact, there is a method by which you can draw or you can analyze this system by considering a composite system. But that I will not consider in this session. Somewhere else I will consider that. In that case, what you have to consider is, you have to consider axis something like this. You have to consider a curved axis, something like this. So you have to consider a curved axis, and then you have to write equation of motion along this curved axis, and that is basically one line solution, and you can get the acceleration of this object. So I hope you like this video, and if you like, please share with your friends and comment in the section below, and I will see you in the next video. Thank you.